So here is our do now for today. Take a minute, pause the video, give it a try on your own, and then when you're ready, hit play to check your work. So for number 1, it says the distribution of the diameters of ball bearings made under a given manufacturing process is normally distributed. So as soon as I see the phrase normally distributed, I should be underlining it or highlighting it because I know I can now draw my normal curve, which is a single peak bell curve with a mean of 4 centimeters, so mu equals 4, and a standard deviation of 0.2 centimeters, so sigma equals 0.2. What proportion of the ball bearings will have a diameter less than 3.7? So proportion, I'm thinking probability. So I'm going to label on my graph, my mean is 4. They want to know less than 3.7, so I'm going to label that number. And because it's less than, I'm going to shade to the left of that value. We should be going on our calculator to normal CDF. It asks for 4 things: a lower bound, an upper bound, a mu, and a sigma. So you already have mu equal to 4 and sigma equal to 0.2. Your lower bound is the left-hand side, so look at your shading. You shade it all the way to the left and you keep going and going and going and going to negative infinity. But we don't have something like that on our calculator, so we just use a really big negative number. So negative 1 million, 10 million, something like that. My upper is this bound here where I want to stop, which is 3.7. So remember, on your calculator, you're going to hit second vars, which is next to the clear, choice 2. Negative, a really big number, 3.7, 4, and 0.2. Paste. Here's my value. If I go back to my worksheet, I'm looking for the rounded value of that, which is choice 1. Number 2, which histogram depicts data that is least likely to be approximated by a normal distribution? So what I would do here for number 2, remember that a normal distribution is like what we just drew in number 1. It's a single peak and it's bell-shaped. So if I trace roughly over each of these, which one is least likely, it would be choice 3. And that would be because this is skewed to the right. Here's my tail on the right-hand side, so it's skewed to the right. So our target for today is at the end of 42 minutes, I can calculate z-scores and interpret their meaning. So what is a z-score? A z-score, also known as a standardized score, is the number of standard deviations a score is away from the mean for a normally distributed set of data. So here is our formula that you need to know for z-scores. Our formula is z equals value minus mean over standard deviation. So in symbols, a lot of times if you move on to AP statistics or other higher level math courses in college, x minus mu over sigma. X is your value, mu is your mean, and sigma is your standard deviation. So if z is positive, if your z-score is positive, that means the score is to the right or above the mean. If z is negative, the score is to the left or below the mean. And if z equals 0, the score is at the mean. So let's draw a little picture here. Here is my normal curve. Here's my mean. So at this point here, that's z equals 0. And everything this way to the right of the mean or above is a positive z value. And then everything to the left is a negative z-value. And z-scores are used to compare different data sets together. For example, boys' heights and girls' heights, ACT scores versus SAT scores, or even SAT scores in general. If you took the SAT in November and your friend took it in December, there's a different test. So you can't necessarily compare them to each other because there's going to be different means and standard deviations. But by creating a z-score or a standardized score, it allows us to compare them. So let's take a look at the practice problems. IQ scores are normally distributed, which is good because as soon as I see that, I know I can use my normal curve and my z-scores with a mean of 100 and a standard deviation of 15. Find the z-score and interpret it for a student who has an IQ of 90. So if we're looking for symbols, x would be equal to 90. But I'm going to write my formula out in words. Z equals value minus mean over standard deviation. So my value is 90, the mean is 100, and my standard deviation is 15. So before I even go to type this in my calculator, I just want to think about a picture for a second here. Here is my normal curve. My mean is 100. My value is 90. I'm below the mean or to the left of it. So that means I should be anticipating a negative number when I type this in my calculator. So I'm going to go to my calculator. I'm going to hit alpha y equals to set up a fraction automatically. 90 minus 100 over 15. We get negative 2/3. So negative 2/3 is okay, especially because there were not rounding directions here. But when you move on to upper level maths, z-scores are always going to be measured as a decimal, and it's going to typically be two places. So I'm just going to put that in my notes as well. I'm going to hit math, choice 2 to put it as a decimal, and I get negative 0.6 repeating. So two places would give me roughly negative 0.67. And now remember, they wanted me to interpret it. So whenever you interpret it, you must do it in context, which means I have to refer back to what the question was talking about. And it was talking about IQ scores. So someone who has an IQ score of 90 is 0.67 standard deviations below the mean. And now notice I did not use the negative in my explanation. I put a 0.67 and then I used the word below. If it had been a positive, I would have put above the mean. Let's take a look at number 2. The prices of the printers in a store are normally distributed with a mean of $240 and a standard deviation of $50. The printer you eventually choose costs $340. Find the z-score for your printer. Interpret what this means in context. So I have z equals value minus mean over standard deviation. So substituting in, I'm going to get 340 minus 240 over 50. Once again, if I just wanted to sketch out a little bit of a picture here to help visualize it, my mean is in the center. It's 240. My value is above the mean, so I should be anticipating a positive value. Because remember, A z-score measures how many standard deviations you are away from the mean, either above the mean or below the mean. So in my calculator, alpha y equals 340 minus 240 over 50, and we get 2. So I get 2, and now I need to interpret what this means. So a printer that costs $340. Whoop, it's decided to stop writing. $340 is 2 standard deviations above the mean. So what does that mean, really? It means the printer costs more than most printers. So if you wanted to add that as well, you could. The printer costs more than most printers. And that's my interpretation. So if you remember, a z-score is the number of standard deviations away from the mean. So if you're at the mean, my z-score is going to be 0. And we talked about that when I gave you the definition and I drew that little picture. So if we're referring to the z-score, our mean is going to be 0 and our standard deviation is going to be 1. I can draw out a little normal curve. Here's my mean. This is 0, which means I have 1 and -1, 2 and -2, and so on. You don't really need that picture, but that's what we're going to be talking about in the next few questions. So how can we use normal CDF with z-scores? The same way we have been. We're going to draw a picture, we're going to label, and we're going to use our calculator. Find the percent of scores that fall between the z-scores of -0.6 and +0.6. On the normal curve, and then round your answer to the nearest thousandth. And just be careful here because we're finding a percent and then I'm rounding. So with normal CDF, I'm always going to draw my picture. I have my mean. These are going to be your bounds. So I want between. So -0.6, +0.6, and I want between them. So remember, for normal CDF on the calculator, you need 4 pieces. You need a lower, an upper, a mu, and a sigma. So my lower is -0.6, my upper is +0.6. And when you are using z-scores, these last 2 pieces will always be the same. They will always be 0 and 1. So I'm going to go to my calculator. Second, bars, choice 2, -0.6, +0.6, 0, and 1. I'm going to paste. It's going to calculate it for me. I'm going to copy everything down. 0.45149338 and so on. I want a percent, so I'm going to move it 2 places. So 45.14938 and so on percent. And then nearest thousandth, I have 3 places. So 1, 2, 3, go 1 past it. The 3 tells me to stay. So 45.149%. And let's do one more of these where I want you to find the percent using normal CDF. So find the percent of scores to the left of z equals negative 2.4. I'm going to draw my picture. Here's my mu, which I know I can label a 0 because I'm on the z-score or z-scale. I have negative 2.40, and I want to the left. So I'm going to use normal CDF, which means I always need 4 pieces. I need my lower bound, my upper bound, my mu, and my sigma. Mu and sigma, since I'm on the z-scale or using z-scores, are going to be 0 and 1. I'm going to the left, which means my lower bound is negative 1 million, or a really big negative number, and my upper bound should be negative 2.40. Back to my calculator. Second, vars choice 2, negative a really big number, negative 2.40. 0 and 1 are going to stay the same. I'm going to paste it. Here's my probability. I have 0.008197.5 and so on. They wanted a percent, so I'm going to move it 2 places. 0.81975%. And they didn't give me rounding directions, so I'm going to round on my own to the nearest tenth. So roughly, whoops, sorry guys, roughly 0.8%. Or if you wanted to round, you could say roughly 1%. Let's take a look at a Regents question. There are 400 students in the senior class at Oak Creek High School. All of these students took the SAT. The distribution of their SAT scores is approximately normal. The number of students who scored within 2 standard deviations of the mean is approximately. So I don't have a mean and I don't have a standard deviation. When you don't have a mean or a standard deviation, we're going to use z-scores because 2 standard deviations is your z-score. Because remember that z-score measures the number of standard deviations away you are from the mean. So that means I have z equals negative 2 and z equals positive 2. So I can draw my picture of a normal curve because it's approximately normal. My mean is always in the middle, and because I'm using z-scores, my mean is 0. So I have negative 2 and positive 2, and it wants to know within, so that's the same thing as between. So I'm shading in here, which means I can find the probability by using normal CDF. So my lower bound is negative 2. My upper bound is positive 2. Because I'm using z-scores, mu is 0 and sigma is 1. Second, vars choice 2, negative 2, positive 2, 0 and 1 stay. Paste. Here's my percentage or my probability. So I get 0.954499 and so on, but this is my percent or probability. And by looking at the answer choices, I know that that seems wrong, but if I converted it to a percent, I could possibly say 95, but I want to read my question carefully. It says the number of students who scored. So I am looking for the number, which means I need to take my 95% and multiply by the 400 students they told me about. So I'm going to go back to my calculator. That value is already stored in there, so I'm just going to hit the times button, 400. So I have roughly 381 students, 0.79. So let's go back. 381.79. Looking at my answers, approximately, it rounded for me. Choice 4, 380. So you guys are going to try the practice problems on your worksheet, and then when you're done, make sure you submit your answer via forms.